Good morning, everybody. Thank you for joining us for our webinar this morning from a rather wet and chilly Cape Town. We greet everybody across the country, and we're really happy that you've all taken the time to join us this morning. My name is Conrad. I'm co-hosting this morning with William. William is our product manager for our automation, variable speed drives, and power supply products. And he has many years of experience and knowledge related to these products. So just a couple of rules before we begin regarding the webinar. Like I said, my name's Conrad. You can see William in the little video caption as well. We've muted everybody's microphone and we've switched off your cameras just to ensure that we get the best bandwidth on the webinar. And you'll see that you have three little boxes or little flags you can tag. If you want to raise a question, please either raise your hand if you want to ask it live, or use the Q&A section to ask your question. We tend to try and answer questions live during the presentation so that it's relevant to the slide that we're on or the slide just before. And then if there's a general chat and you have any issues with functionality, just use the general chat function, please. I monitor this during the entire webinar, so I do react real time. At the end of this webinar, there's a very short poll. Please just take the 1 minute that's required to fill in the poll. It really helps us ensure that we deliver the best quality webinar that we can to our customers that is engaging and full of content-rich information. This is a two-way street. We don't like to talk to ourselves. It's a bit weird. So if you have got questions, please engage with us. We really do like answering questions. Today's content, we're going to look at linear power supplies. Let's call it old technology. We'll then look at switch mode power supplies, the modern way of giving you 24 volt DC, 48 volt DC, 12 volt DC. We'll look at the electromechanical range. What have we got to offer? It's a comprehensive offering that we have. Then we'll look at complementary units, so redundancy modules, backup supply, diode modules. And then we'll look at some of the applications that you can use power supplies in. Power supplies are often overlooked. You know, it's a product that sits in the catalog, and we do have quite a robust offer, and we do sell a lot of these products, but it's never really paid much attention to. But in almost every control panel, in almost every motor control center, in every instrumentation panel, you are going to find a power supply. And we hope that you find the information this morning relevant to the products and that it will make you think a little bit more in future about power supplies. So with no further ado, William will now take over. Please have your catalogs ready. From page B57 to B58 is where we will concentrate, and we will refer to the catalog during the webinar. Thank you. William, you're still muted.
Thank you, Conrad. Let's get into it, ladies and gents. So the session will last roughly 30 minutes, so it's not going to be a long session at all. To start from the beginning, like I always like to do. So power supplies, you can basically break them up into two main categories. Your linear power supplies, as you see on this slide, is a very basic type of power supply made up of 2 to 3 components mainly, which is your step-down transformer, your bridge rectifier, filtering, and possibly a regulator as well. These type of transformers are very basic to build and basic to repair. That's the one pro that they do have, but they're very bulky and heavy. And to increase the filtering of these type of transformers becomes very expensive as you're adding more and more copper and also very inefficient type of transformer, type of power supply. roughly 40 to 60% efficiency compared to a modern day switch mode power supply. That's very poor. They are good for one thing, it's mainly radio communications due to the low noise that they present on the output compared to a switch mode power supply. So good for radio devices, but that's about all. So very basic circuit, as you can see in the picture, made up of 3 to 4 components only. Looking at the modern day switch mode power supply, you can see by the control circuitry that it's much more complicated. The control diagram on the right-hand side is simplified even, so it's even more complex than what's illustrated. A number of components make up the power supply. Compared to the linear supply, it's very small, lightweight, and compact. Powers above 15 watts is very cost effective. I think your linear power supply might still be more cost effective below your 10 to 15 watt region, but anything above 15 watt switch mode power supplies become much more attractive. Stable output voltage due to the feedback that is sent back to the controller. So if there's a dip in voltage due to perhaps a high load or an inrush, outrush current, the power supply can react by having this feedback system back into its control circuit to increase the output, to maintain a very steady 24 volt or 12 volt output. Compared to a linear power supply, which wouldn't have such feedback, it wouldn't be able to react in the same way that a switch mode does. Very high efficiency, up to 92%, and compared to the linear type of 40 to 60%, it's in a different league altogether. Contrary to the linear though, not ideal for radio instrumentation. Perhaps you do get specialized switch mode power supplies that are suited for that, but your general type wouldn't be due to the high frequency switching that happens internally in the switch mode power supply, as the name suggests. They are complex devices and fairly difficult to repair if it's not your profession. That's one other downside to the power supplies, but with the modern day technology, they are designed to work 10 years plus. So you shouldn't need to repair them unless something went wrong on site. All right. Just a note on the switch mode power supplies. Something I remember picking up as an appy many years ago is the switch mode power supply's inrush current. Typical at a cold start, really. So what I mean by a cold start is when the power supply has been off for, say, a number of hours and its capacitors are completely drained. When you turn on that switch mode power supply after a lengthy off period, you would have a sudden inrush. And the inrush current is many more times than, say, 10 or 20 times the rated nominal input current of that power supply. So it's something to consider and to remember. You can have nuisance trips if you try and match your circuit breaker, your upstream circuit breaker, too close to that nominal input current of the power supply. There's two ways to get around this problem. Number one is increase your circuit breaker's nominal current. I typically go for the 6 amp, like NF106 for your single phase input breaker. It gives you 6 amps at 5 to 10 times inrush current. It's enough to cover a wide range of power supplies that use single phase. Also, the reason for the 6 amp is you note that it's a little bit cheaper than anything lower than that, the 3, the 2, and the 1 amp, namely. So the 6 amp is one choice you can go for. If your typical power supply nominal current is, say, half an amp or 1 amp, then multiplying that input by about 5 times should be enough to save you from a nuisance trip. Another way around the problem would be to use a D-curve breaker, used primarily in motor starting direct online applications. But the D-curve has obviously the curve to filter out this type of inrush current that you could experience. I remember back in the day when I experienced these types of problems, couldn't really figure it out. But you would turn the breaker on and it would trip immediately. And the next time you turn the breaker on, it wouldn't trip because it obviously charged up a little bit the first time. So the second time you reset the breaker, it wasn't effectively a cold start anymore, as the caps would have a little bit of charge in them. Just highlighting the specs of the inrush current, I'm just going to look at our DRP series. So you note that they don't specify a particular value, but rather that it won't exceed a certain amperage. So a typical C-curve breaker, you know, is 5 to 10 times the rated current inrush. At a 6 amp breaker, you're looking at 60 amp inrush that you can have on a 6 amp breaker, basically. So just something to take note of and maybe to be aware of when you do specify a circuit breaker or a power supply. These are important questions when you select a power supply. What is the input type? Is it single phase, 2-phase, or 3-phase? Your output power, your output voltage obviously as well. What's the wattage and the voltage? And then my most important one is efficiency and reliability. In our range of power supplies, you get low-end power supplies or high-end power supplies that have a different efficiency. So, you know, it comes down to power saving potential and at the end of the day, cost saving as well. But the next point is reliability. To ensure good reliability in a power supply system, it's my rule of thumb and Delta's as well that you should always have at least 30% buffer in your power supply compared to your load. So in other words, a 90-watt load, you would want to go for a 120-watt power supply. This just makes sure that there's enough capacity from the power supply, and it does prolong the system life. So a great way to ensure reliability is just to add that extra 30% onto your actual power consumption in terms of your power supply output. We're going to look at the different ranges that we stock. Each range has something to offer, be it a compact dimension or a price advantage or a special feature. So I just want to take a few minutes to go through the range and highlight any features that might be applicable. So starting at the Sync series, the DRS, that's the DIN rail sync, obviously DIN rail mount, very well priced, and it has a plastic frame, up to 89% efficiency. We've got the 12 and the 24 volt versions in our catalog, as well as one that's not illustrated, that's fairly new edition, is the 5 volt DRS with this part number that I'm highlighting over here. So that's a 5 volt power supply, also in stock in the DRS range. It's got a wide input AC range, 85 to 264, as well as DC input range. Very high failure, mean time before failure. It's over 700,000 hours. And our power range is relatively small, only 15 to 100 watt. So that's the DRS. Looking at the DRL, or the DIN Rail Light series, also very well priced, comes in plastic and aluminium packages, up to 90% efficiency, so a little bit more than the DRS. We only have 24 and 48 volt versions in this range. Also wide AC input range, no DC input on this unit. Very high mean time before failure as well, 700,000 hours. And our power range between 75 and 480 watts. Also just want to highlight the DRL 24 volt 75 watt unit. This is new to the 2020 catalog. And it's extremely well priced in the DRL range. And also enjoys a very, very narrow, slim design. You can see by the little table we put together that it is the narrowest in its class. So that's a very good power supply to consider as well, the 75 watt DRL series. Looking at the DRC, DRC DIN Rail Chrome power supply, it's compact design, it's modular, has double insulation, so there's no earth terminal required. Comes in 5, 12, and 24 volt versions, as you can see on page B58. nice wide AC input range, a decent efficiency of 87%, decent mean time before failure, and it's also very well priced. It's got a great operating temperature range, -25 to 71 degrees, and a small power range of only 10 to 100 watts. But great compact power supply, perfect for your DB boards, modular package. The widths are modular. I think it's 18 mils as your standard modular design. And as you can see here, this is just a couple of snapshots from our building where we've utilized these Chrome series in various DBs around the offices. So you can see the nice form factors, fit snug next to your circuit breakers. And also in our main DB, we've got the 100-watt Chrome as well. So very nice aesthetic power supply. You can use it in the residential areas or inside your DB as well. Looking at the little bit more advanced series, we're going into the CLIQ range. We offer the CLIQ 1 and the CLIQ 2. So let's have a look at the CLIQ 1. Plastic and aluminium housings. This power supply does not derate its wattage across its entire AC input range. Often some power supplies, if you're only giving it 90 volts AC, you won't get its full wattage out. But in the DRP range, that's not the case. You've got full power range across the entire AC input spectrum. It also enjoys power boost, which it's able to give 150% output for about 3 seconds. This is great for inductive loads. If you're triggering a lot of solenoids or fans or small DC motors, it's great to have that power boost feature to ride through that sudden outrush current that the inductive load may present. 12 and 24 volt versions, like I mentioned, wide AC input range, also DC input range. Apologies, this is actually incorrect. This is actually up to 800 volts DC. Efficiency 88%, and also a decent mean time before failure. This is model dependent, so I didn't give a particular number. It's different over different model ranges. The CLIQ 2 is our most advanced type of power supply we stock from Delta. They have other series that are more advanced, but in terms of our stock holding, this is the bee's knees. Full aluminium housings. Again, we don't derate any power across the entire AC input range. Power boost is 150% for 5 seconds. So even better for your active loads than the CLIQ 1. That's 24 volt, not 124 volt. So 24 and 48 volt versions. And then as well as single phase, 3-phase and 2-phase operations. Again, model dependent, but we have single, 2-phase and 3-phase AC supply input available in these power supplies. DC input range is 450 to 800 volts, similar to the previous CLIQ series, and efficiency up to 92%. So the reliability, as you can see, is very high, up to 800,000 hours, and efficiency of 92%. You can immediately see that those two factors put the CLIQ 2 just a little bit above the rest. So you're going to pay a little bit more for the CLIQ, but you're going to enjoy a much higher efficiency and a long longevity from this type of power supply. Power range from 60 watt all the way to 960 watts. You can see that's the big boy down at the bottom here. It's 960 watts, 40 amp output.
There's a question, William.
Yes.
Regarding efficiency. They would just like some clarification on the impact of the efficiency on the product. What does it mean in relation to the product?
Well, if you have a 100-watt power supply that's 90% efficient, that means you're basically putting 110 watts into the power supply effectively, and you're losing that 10%. So you're wasting 10 watts of energy continuously, say at full load. That's in heat. That adds to the heat in your panel. Those are things that you don't want. So an efficient power supply is a power supply made up of quality components, designed well, and it's capable of running at a lower temperature, which makes it more efficient effectively. So if you get a power supply 80% efficient, 75% efficient, it's just generating more heat, you're wasting energy, and you're basically heating up your panel for no particular reason. So efficiency is basically how much energy you are or aren't wasting. And it comes down to heat and to money. I hope that answers the question.
Thank you.
So looking at the input voltage table for the CLIQ and the CLIQ2 series, you'll note that CLIQ is only single phase input. And then when we get to our CLIQ2 range, the three-phase versions, we have 2 and 3-phase operation. So if you buy a 3-phase power supply from us, you don't necessarily have to supply 3 phases to it. You could supply 2-phase 400 volt. And instead of a 3-phase breaker, use a 2-pole breaker, and obviously save a little bit in that sense as well, and in your wiring time. So the CLIQ2, as noted here, they are capable of 2-phase as well as 3-phase operation. All right. You see, if you go for 3 phases, you can go low as 320 volt AC. For 2-phase operation, only as low as 360 volt AC. In South Africa, we shouldn't go lower than 360 volt. If we do, then there's other problems at play. All right, so that's the input voltage range of the CLIQ and CLIQ2. Something to take note of. Just an application on the CLIQ2. Here we've got an application where the drive is used as a solar drive, so there's no mains voltage connected to it. Direct connection from the solar array between 500 and say 800 volts DC. The solar array is connected directly to the CLIQ power supply here on the bottom, and the CLIQ drives 1, 2, 3, 4, 8, 10 fans. There's another 2 over here. So it's driving 10 fans, DC fans, at about roughly estimated at 224 watts at a 240 watt power supply. We're a little bit on the limit there, but what I want to highlight is that the CLIQ2, with its power boost function, is able to start these fans all together without any issue, as it can ride through that 150% boost for 5 seconds or more. So just an application where we have direct DC input and we need 24 volt DC output to these fans. Looking at our panel mount type, often overlooked, very, very well priced type of power supply. 90% efficient, so very decent. You can base mount them or side mount them, which makes it quite versatile in your panel. It offers a great space saving potential where you can mount them not on the chassis plate, but on the side or on the roof or on the bottom. So great space saving potential for these PMT ranges. Quite a wide range from 90 to 264 volts AC. Some of the panel mount power supplies would have a little switch on the bottom to change over from, say, 90 to 130 volts or 180 to 264 volts. So depending on what country you're in, America or South Africa, you would just flick the little switch on the bottom of that PMT just to change that input voltage. So it's not a true entire range like it's illustrated here, but you'll note that some of them would have a little dip switch to change their voltage input. If you look on page B58, that's specified by the little red star, that those power supplies in particular would have the little dip switch at the back. I remember as a kid playing in my dad's workshop, and if you've noticed, the little computer power supplies also have a similar little dip switch for 115 or 230 volt. And me being an inquisitive youngster, while the computer was on, I flicked the switch to 115 volts. So you can imagine what have happened after that. So the voltage switch has great memories for me from my childhood. Last but not least, in terms of the power supplies, is our specific PLC type power supplies. So the DVP, sorry, power supply, the ones at the top here for our DVP range PLCs are actually one of the most popular in the catalog, believe it or not. People do like these type even when they're not using a PLC. We saw quite a lot of the 2 amps in particular. So yeah, these power supplies are mainly for PLC systems when you want to keep the aesthetics the same. If you've got a DVP frame, it looks nice with the DVP power supply, and the same with the AS PLC, and the same with the AH500 PLC. Basically, only the DVP series power supply is a general type power supply. The AS and the AH500 are really only designed for those particular PLCs, and I wouldn't suggest buying these for any other reason but the PLC rack itself. But the DVP type, if 1 amp, 2 amp, and the 5 amp, it's a general type power supply, and you can use it just about anything. We're going to have a look at the complementary modules. We'll start out with the UPS type. So these are great little modules. We've got two frames over here. We've got the Chrome frame, the modular frame, as well as the CLIQ in UPS. That's on page B58. So the Chrome is a 10 amp UPS, and the CLIQ is a 40 amp. They enjoy a 0 switchover time. So from mains failure to battery, it's instant. You've got LED indicators on the unit for battery fail, battery charging, reverse polarity, discharging, battery open circuit, etc., etc. As well as 3 relay contacts for discharge, battery fail, and DC OK as well. So these are nice. You can tie it back into the PLC, and the PLC will know that power is down and we're running off battery power. It can send alarms back to the controller, for instance. Just having a look at the diagram for wiring such a UPS into the system. So you've got your standard Delta power supply feeding into the input of the UPS. The output of the UPS will go to your buffered load, and say an unbuffered load, one load that would switch off if there's a power failure, can be connected directly to the power supply itself. The battery is a 24 volt battery, 15 amp hour, 30 amp hour. The bigger the amp hour battery you go for, the longer it's going to take to charge it up. That's about all. So this is a great little design for a basic UPS and a PLC control system. Another complementary module is the redundancy unit. You got a 20 and a 40 amp option, where 22 to 60 volt DC input in this redundancy module. So 24 and 48 volt versions will be supported. It's a parallel and redundant operation. So if you would like 2 10 amp power supplies helping each other out, you could configure it in like a parallel operation. If you're doing it in parallel and you want the power supplies to assist each other, then it's just important that you make sure that the voltage potentiometers and the output voltages of each power supply are very close to each other, so that one doesn't carry more load than the other. In redundant operation, if you just got the second power supply there for a backup, then obviously balancing the voltages out to 5% or whatever is not that necessary. One power supply will do the work. If it fails, then the other power supply would automatically take over anyway. So that's the DRR redundancy module, 20 and 40 amp options. Thank you, gents. That's all from me for today. Just a note on the circuit breakers and surge protection webinars we have lined up as well. You can register at em.coza. And yes, that's all from me for today. I'm happy to take any questions if there are any.
Thank you, William. The crowd has been quite quiet today, so I would assume from that you've been quite thorough in your presentation and have explained everything to everybody's satisfaction. Just a note that a copy of this webinar will be available and emailed out to all the attendees. And if there's anybody that wasn't here today, but if you think that they would benefit from this webinar, please feel free to send us their contact details and we will happily forward a copy of the webinar onto them. There are some, if you can just scroll back one slide, William. There are some upcoming webinars to look at, ladies and gents. Circuit breakers on the 3rd of September. That will be hosted by Christo van Rensburg. He's the product manager. And then surge protection on the 1st of October. And if I'm not mistaken, that's co-hosted directly with Den as well. So we will have some experts on the panel. Yeah, thank you. It's been great having everybody. Don't forget, please, to take the 1 minute to complete the poll when William starts the poll. That really does help us. Thank you for your time and goodbye.
Thank you, Conrad. Cheers all. Thanks for joining. I've just launched the polling, so please take the time. Cheers again. Bye.